Greetings, folks, and welcome to the Electromaker podcast. And this is a very special episode because recently I had the pleasure of talking to Eli Hughes. Now, those of you who have been following the show for a while may remember I did a long breakdown of a project on the Electromaker Project Hub called the Guitar Active Pickguard version 2, which is a PCB that replaces the pickguard of a guitar. It takes readings from the guitar strings as analog readings using piezo pickups per string, and then does DSP in the guitar to do amp modeling or pedal modeling, and then outputs it via AES3. At least that's what the old version did, but the new one is very exciting because it's all being done wirelessly. It's going to be collecting all of the data on board, doing all of the processing, and of course giving you a very nice live sound. But then when you put the guitar down, it will transmit all of the data of every single note you have played on that guitar to the cloud so that you can find everything that you've played, and you can get that riff back that you didn't press record to get when you were doing your session. It's a really wonderful idea, and the conversation we had was far-reaching. Today you'll hear a small edited version of it, along with a few other normal Electromaker Show things, including the winner of our Raspberry Pi competition. But the full version of this interview will also be put out relatively soon as a standalone podcast on this channel. So if you do enjoy what you hear, do check out the full conversation with Eli. He is a very inspiring person, not only because he is a very experienced engineer, but also just a very nice attitude about everything. He has this idea of being the full stack embedded engineer. And this doesn't just mean knowing all of your disciplines from coding through to electronics. It's about being someone who can work in a team, about someone who's can be an educator, about applying a beginner's mind to everything. And you can probably tell from the fact that I'm having trouble finishing this sentence that I got on quite well with him, and I'm very excited about sharing this. Before we start the show, just the usual thing. If you are in a podcast app that allows you to rate the show, please do. Please leave a comment about the things you enjoy about it. And if you head to electromaker.io/shop, you will find a full variety of things that you can buy, including the Raspberry Pi 5 as featured in this show, and the NRF7002EK, which is the Arduino form factor shield for their Wi-Fi 6 chip, and a lot of other things from most other manufacturers and suppliers as well, including Adafruit and Sparkfun. Anyway, with that rather mammoth intro out of the way, let's get on with the show. So we're going to begin with that interview with Eli Hughes, and what you're seeing here is a very, very cut down version of a long conversation that we had, but we're going to focus today purely on the Guitar Active Pickguard project. It will be the first link under this article, and I recommend maybe giving it a read through before you listen to the interview, just to get context. But what I am actually going to do is introduce Eli back when I spoke to him, and then I will cut back in to give a very high overview of the project so that you have context for the rest of that conversation. Hey folks, this is Ian from Electromaker, and today I am joined by Eli Hughes, a hardware and software designer, a musician, and an educator. From an early light bulb moment noticing that the Nintendo Entertainment System and the Apple IIe shared the 6502 processor, his path through education and into the industry has covered many disciplines, culminating in an idea referred to as the full stack hardware engineer, something I resonate with a lot. Alongside spending time as a research engineer at Penn State's Applied Research Lab, Eli has co-founded numerous companies, including T0, using acoustics to monitor fermentation levels during beer brewing, among other things, and Wave Number, whose Bunny Vision projects combines multiple disciplines, including training models for object detection on a microcontroller, and using cutting-edge displays to show data to the rider.
Right.
Those of you at Electromaker may well know Eli's work as well, as he is the author of the Active Guitar Pickguard project on the Electromaker Project Hub, something we will be discussing more today, among other things. Eli, thank you so much for joining me. I hope that intro was okay. Feel free to add anything I may have missed.
No, it's perfect. Thank you.
So there are a number of things that that we could talk about today, but one of the things that, as I mentioned in the introduction, people who are familiar with Electromaker would have probably seen your work through the version 2 of your Guitar Active Pickguard. And the version 2 combines your own development board based on one of the newer NXP parts, the number of which, I have right in front of me actually, the RT685. And interestingly uses one of the new Nordic parts for data transfer, which is the Nordic NRF7002 Wi-Fi IC. Before we get into it, I want to give a quick high-level overview of the inspiration for the project and the project itself, because we're going to get into the technical details, and this might just be some useful context. So the inspiration behind this guitar pickguard was actually a keyboard, the eSonic ZR76. It was a sampler and synthesizer that was used by a multitude of people, and it's been responsible for a bunch of hits, hip-hop hits. It's been used in R&B and pop, all kinds of stuff. But what made it really interesting is it had a ring buffer inside it that stored every key press and every button press for a certain amount of time, just in the background. You never had to press record, which meant that if you played something a few minutes ago that you liked, you could just spool back through and it would play it back to you, which was a very interesting concept. Eli took this idea to heart, and this was the basis of his first active guitar pickguard project, and if you'd like to know about that, look at the project page linked below. The second version follows on from it like this. Again, you have per string piezo pickup, so each one of the strings is picked up at its full frequency range, and that analog signal goes through an ADC into the SuperMonkey development board, which is based on the NXP i.MX RT685, a very chunky CPU with a very nice DSP on the same chip as well. And that's where all the fun DSP happens. You can make your guitar sound like a vintage tube amp and a vintage guitar, or you can make it sound like space lasers, whatever you want. And after that, this is where that audio goes out to an amplifier, to a speaker, straight into a recorder. Again, you have full control over the sound output. The old version also had an AES3 output, which is a data platform which is designed specifically for sound. I've looked into it a little bit and it's very interesting, but it's a complete story for another day, absolutely. But it is a close to lossless output, which is another very interesting way of outputting your data. Now, where things have changed and where this gets really interesting is the addition of the Nordic Semiconductor NRF7002EK. Eli mentions in this interview that this specific chip has a very interesting set of parameters that make it great for use. Not only is it very low power usage and you get very high throughput, it has a quad SPI that allows you to get very high back and forth data, whereas a lot of other Wi-Fi chips use UART. And the reason that it's in this project is that idea of saving everything that you've ever done, you can only save so much onto the onboard memory of the board. But then you're not going to play the guitar all day, so when you put the guitar down, it uploads all of that data, all of the audio data, all of the DSP data, whatever data you wish to capture, to the cloud. And there you have cloud storage of everything you have ever played. And as Eli says, once you have storage, then you have multiple options for how you interact with that storage. That's where AI could come in order to sort it into things that you might want to keep and not want to keep. And again, since all the DSP is happening on board, you could just decide to take the audio, pure raw audio from the pickups that you got, and then put it through another DSP algorithm, giving you a completely different guitar sound and feel. So that's where the project comes from, and we'll pick up the conversation where Eli starts talking about getting it up and running and some of the design choices involved.
There's just so many things you can do with that data once you have that raw data in a form that you have it, and you didn't really have to do any work to get it.
Absolutely, yeah. Well, I suppose one thing we should probably do, given that this is technically supposed to be about technical hardware stuff, albeit from a high level. We have a wonderful amount of data collected that is going to go into a guitar, and on the other side you have the cloud or a local storage system, whatever. What you had in front of you, and throughout this project you explain, is a brand new development board that you put together, which, again, you can go into the reasons why in a moment, which should have been a lot harder to get working with Zephyr and things than you'd think. But of course, thanks to overlay files, there was some groundwork there done. And then on the other hand, you have this Nordic part, the NRF7002IC, although it's actually in the EK format, which is an Arduino form factor shield. And I always say that very carefully because I always like to say I frequently say Arduino form factor 3.3 volt shield. Yeah. But these are two very different parts from very different vendors. But as we talked about a little bit before we went on air, we're both kind of a little bit, we're quite fans of the way Nordic have approached things since they built their stack on top of Zephyr. And of course, the NXP parts all work with Zephyr as well. So what was the process you went through in order to get these two parts talking to each other? Because it's not the same. When you come to Zephyr, it's not the same as having to really build your own thing from scratch, is it?
No, and I'll weave in of like why that part, because there was a specific reason for that part versus something else. So like, just backing up, part of the reason for that part, started, before the 7002 was that even prior to Zephyr, I've done a lot of everything from assembly language to bare metal, RTOS, free RTOS, micro C, RTOS, Zephyr was something when I, was using a Nordic part right as about the time they were phasing out their kind of classic SDK. They were starting to bring Zephyr in, and I was initially skeptical. I was like, I'm going to do this bare metal my own way, until I spent the time to really understand why they were doing it. And I actually met with some people from Nordic to explain why in the context of some of the Bluetooth work. But and once I understood the intent, it made perfect sense. And the ability to construct new things from old things very, very quickly, for the business I was working at the time, it made so much sense. And then I kind of became like not only a Nordic fanboy, but a Zephyr fanboy, because it solves some problems that in the 20 to 25 years I've been doing this, I see the same problems being redone over and over again. Yeah. And there's some things, while you might not, care for the way it does it, or you might prefer a different system, the fact that it's standardized, documented, tested, and has a healthy community means that you can progress really fast, once you're plugged in. The 7002 in particular, there are other Wi-Fi parts, right, that are kind of Zephyr compliant, right, that they generally, though, the challenge is they're not terribly fast in their interface. They're kind of designed to go over like a UART, or even just SPI in kind of a crude way. And while this didn't have to be super fast, a UART is probably a little too slow. And just knowing my previous history with the NRF 9160 on a cellular project, and just how slick the networking worked. I mean, we were able to develop for a different project, not only get it work on the 9160, but an entire CI/CD pipeline around Zephyr, and all the code could be tested on a different board package running on a PC to check the whole networking stack. Yeah, it sold me. And when the 7002 came out, it had, when I saw it, there was two features. I just knew it was going to be first-class support for Zephyr features, Wi-Fi, networking, because Nordic is into it as anyone, but it also has a Q-SPI or quad SPI interface. And so does the RT685. The NXP kind of had pioneered the quad SPI interface in 2010 or external flash memory. The RT685 has multiple of these ports, in that you could get a reasonably fast, much faster than UART or single bit SPI. You get quad SPI. So that was just another feature that just didn't exist anywhere, along with all of the Wi-Fi 6, characteristics of kind of reduced power, so on and so forth. So as a companion type IC, it was like such a no-brainer. Coupled with my previous experience with Nordic was that you might have the EK or some of their DKs, but they kind of give away the the Altium files and whatnot. So getting to an actual layout with the part is really quick. So yeah, it kind of all coalesced into just like the right chip at the right time in the right software stack to quickly prototype. One thing I was going to mention that is a little bit that's changed since that article, and is part of your original question of the process. Just because I know enough about Zephyr to know what I don't know, and I've ported enough things to know I can, work with this, kind of bleeding edge. And when I wrote that, it was, they were just getting the Zephyr port like online, working with the Nordic parts. No one had actually ported it, get it to work on a different non-Nordic part. So some of the information in there is actually helpful, even though some of the things I had to do to get it to work aren't really a problem now, because like it's been out for a while. I was on like a pre-release branch kind of version. It's helpful to read it because of the process of how to use device tree and kconfig with the overlays. You can do quite a bit even before a chip's supported to get things to run without even touching source code. And that's kind of the magic of it. Now, that's why when I typed up that article of showing kind of bleeding edge, because while it looks bleeding edge, ordinary people can do it because it's not that difficult once you understand your intent.
The beauty of it as well is that you have, as I gave in my sort of very high level idea of what the project, the Active Pickguard project is before, you have this project which is essentially analog sensors at one end, DSP in the middle, and then analog output plus data output at the other. But also what this sort of shows is the portability of concepts and how Zephyr can really help with that. Because where you have something that does a lot of processing power, you're taking audio and you're doing DSP on it, but someone could just as easily be taking sensor data from an area and doing edge AI on it or whatever, and logging data over a long period of time. And the exact same configuration and the exact same approach that you have taken for this could be applied to many things. While you're working on things like this, does your brain ever kind of say, oh yeah, okay, actually this could also be perfect for this completely different thing,
That's actually mostly the reason I'm really into the ecosystem is that, and there's a lot of discussion, especially in software engineering, of at what layer do you kind of bisect, units of functionality to reuse? Yeah. And it can get pretty heated. And I think in terms of pretty high level of, I don't need to reuse everything, but sometimes if I get 80% of another thing, that's good enough. And just be able to quickly experiment. And, it has the ability, and especially for people who are more on the embedded side, I'll call it classic microcontroller folks who maybe are not used to working on a large software engineering team, maybe they're not using Git or a version control system, of how you can kind of structure things at the right layers of when reuse is important. So even for my company, we have our own set of, every Zephyr, our West Manifest has a common set of utilities we bring in that kind of keep getting reused just to accelerate. And they just came about from, hey, we're doing the same thing every time, unique to us, but it's not really unique to us. It's and just having a system that when you bring someone new on board, it's not like learning a completely bespoke software engineering environment. It's, you can send them literally, actually, engineer at Wave Number, started last fall. That was kind of the training was in Zephyr, that I can say, hey, we have the Zephyr project, go to the Nordic tutorials on Zephyr, spend a week, that's, because once you learn that, that's just not Nordic, that's any Zephyr part, right?
Absolutely, yeah.
So, just from the software engineering in, project management point of view, it was a pretty big deal. But yeah, I do that a lot. And even I had a paper on the Linux Foundation website in cloud connected acoustic monitoring, which is measuring accelerometer over time to do DSP on board, send up, battery powered, same kind of principle, same networking stack as the guitar, the same pieces will be there. So a lot of these things aren't that dissimilar.
For sure, yeah.
So
one of the things that you have sort of mentioned in various form factors in various ways over different interviews, and something that you mentioned in the project is, I'm going to paraphrase you. It's sort of this idea of the beginner's mentality, in that before you tried to attach the NRF7002 EK to a completely new development board, you tried it with one of the evaluation kits of that board. And before you did that, you tried to get an LED to blink on the NRF7002 DK. I mean, this is a bit of an esoteric question, I know, but is there an issue sometimes with people just wanting to jump straight to the end goal without actually just testing, to get things going off the ground,
Yeah, so what I love about hardware, which I'll call hardware and embedded systems, and it's definitely, it kind of wears you down over time of whatever ego you come into it with, it quickly gets rid of that ego really quick. And even after, and I remember very specifically, and the reason, I kind of brought that up in that article, it was in my undergraduate education. My advisor, I was just really addicted to microcontrollers, and we were using in our lab a Hitachi, which became Renesas. Mm-hmm. And it was for my senior project, and I was suffering. And there was a bug in the ROM of this thing, and he came and helped, and we got it done. And he looked at me. Now, this was an engineer who worked for Digital Equipment Corporation, DEC, who worked on the Alpha processor, the PDP-11. And he looked at me. He's like, Eli, shit has always been this way. I don't care if it's 1 year or 50 years of experience. But the reality is like, I'm humbled on probably a weekly basis of, I've done this a million times, and I get a new piece of hardware and saying, take the steps the same way, because you don't know what you don't know. And just getting that LED to and making those steps, it may seem like they're not needed, but it's an investment you pay that you're going to actually probably learn something every time.
Yeah.
In the time I've been doing this, I've yet to see that violated. And every time I thought I could get around it, I was humbled by, the gods of embedded systems said, no, your head's getting a little too big there. We've got to punish you a little bit.
Yeah.
But I have another rule too, like I2C, has been around forever. Simple two-wire communication. There's a rule that if I have a new board and I'm bringing it up, even if I'm reusing software, reusing a hardware design, I hook up the Salier logic analyzer and get it ready. Yeah. Because if I don't do that, the gods of embedded systems say, yeah, you're not ready for failure. It won't work. Yeah. If I'm ready and ready to debug, it's going to go smooth, right? I'm just prepared for, what can go wrong. Because, but no, it's just, I've seen this actually just for some of the other work I do of helping other companies debug problems. In most of the issues, even in with using the most complicated parts, like an i.MX 8, application processor, most of the issues, and I'll even say this at really big companies, think, billion-dollar companies with infinite resources, the issues aren't in these really esoteric hard problems. It's in very simple stuff that was overlooked at the beginning, that an assumption was made that shouldn't have been made, that wasn't checked. And that's why I'm saying, get the dev board, make it blank. I don't care if you have 25 years of experience, don't skip that step. Like,
sure, yeah.
And then just going through it, and just swapping out pieces long term, it'll always go faster.
For sure, yeah.
Just take that mentality every time.
Well, which I suppose brings us on to a similar sort of question, in that I expect that some people listening to this interview will be very much in the position that I was a comparatively short time ago. I've been looking into Zephyr for less than a year. And I have no engineering background whatsoever. I'm just one of those people who picked up an Arduino in the first wave. I did a little bit of stuff before that, but that was the first thing that really grabbed me. And I'm at a point now where I think I know maybe the first step of 1% of Zephyr, and I'm in. I bought into the idea completely. But when I learned it, I followed some fantastic tutorials on YouTube. There's some wonderful tutorials out there. I can't remember what board I actually started with, but you also mentioned that the way that you pretty much onboarded one of your recent engineers at Wavenumber was by saying, get the Nordic dev board and go through the tutorials. Is there any sort of, if someone wanted to get started with the NRF 7002, for example, what do you think would be the best kind of hardware and kind of tutorial or methods to follow, do you think?
Yeah, so there's actually a lot to unpack there. And the biggest advantage of Zephyr is also, it is a challenge. And like Zephyr, when I teach or talk about it, I don't mention it as one thing. It's a collection of things. It's a build system that's standardized. It's the one thing that's very opinionated on is how you build source. There's not a Zephyr IDE. It's like you have West in a tool chain. It's not a vendor specific IDE. So it has kind of like software package management, right? Through like K-config effectively in West. It does have a device driver model, which you actually don't have to use, right? You can choose not to use it and just do as, has a test framework that they run automated tests and documentation. And so each one of those things you can unpack. And I guess I was always, I say kind of lucky that I learned at a time when there weren't nice IDEs. Like the first microcontroller I used was a HC11 from Motorola in college, where you manually invoke the assembler at a command line to make it work. So the best you could do is write a batch file to automate it, but you got a good sense of the tooling as to how it built up. And just over the years, as you see tooling get layered on, you kind of know how it works down to running the command line. And so you know where to start when it doesn't work. It's not magic. That's an important part. And it does take some time to wrap your head around. But once you look at it, it's not one thing. It's just a collection of tools and with documentation on how they work. I really like, for example, the Nordic NRF52 DK there's so, like, it was just at the beginning, like of Zephyr, that it's a pretty easy part. It's easy to use. Like the peripherals are pretty simple. Just going through the Zephyr website, learning how to install, run West build, Hello World, Blinky, is a big deal. And then you can kind of start bringing the automation, because once you wrap your head around that, whether it's the NRF52, rebuilding for the NRF 7002 EK, I think that uses the 5340. It's the same process. You just change the argument, right?
For sure. So I think a lot of people still don't really realize that. When I've said several times, and I've had comments about this, when I say you can change configuration and not even change source code. You can, when you invoke West build, just name a different board and it will build it for that different board without touching the source code or the config files, which is wild to me.
And you can build it for, they have what's called the native POSIX emulator. It generates an EXE that works on Linux that they emulate. You can test everything without a board, right? And
it's weird. I kind of took a backwards route into it in a way, in that I can't remember which board it was, but I had one of the Zephyr supported boards, and I just did kind of the same thing. I had it just installed it, did everything with West, and was just using a very basic text editor, and used that to just get my head around the corner of what was going on. I have a little history with Make, less so with CMake, but I kind of enough to look at something and say, I don't know what this does, but I know why it's here, But then I was discovered much later that, and again, I'm glad I did it in this way round, but I discovered much later that on top of all of this, when I started playing with my NRF 5340 development kit, that time round, I followed Nordic's tutorials and discovered that this whole thing about there being no IDE, and when people say that there's not an IDE these days, it means Visual Studio Code and an extension, And the Nordic device tree extension, I didn't realize this until recently. It's a visual extension, so you can ping things on and off like you would in the Cube IDE, for example.
Actually, what I was going to say, that's probably where the helper tools really come in. When you just have the text editor, sometimes just knowing what the options you have are is difficult when you're starting, right? You don't even know what things you can turn on. And those things are really valuable, I think, of helper tools. The thing actually I found out too, that and when I teach Zephyr from the build system and you run your West Flash to load it, it kind of works hand in hand. A lot of these boards have an onboard J-Link, and it's called the Seger makes the Ozone debugger, which is you have the J-Link, which is it's a Zephyr aware debugger, meaning it's source level, single step, but it knows about your threads that you can kind of use. So you end up kind of building this IDE, kind of how you want. So I definitely, where those plugins and tools have gotten good in the past few years are those peripheral things like Kconfig, device tree, of making it easy just to know what the options are without having to hunt through the source code.
Absolutely, yeah. I feel like I could talk about this forever, and I'm sure there are other things that we could talk about, but just this juncture might be a good time to point out to anyone who is interested in getting started with this. Any of the learning resources that we have been kind of idly chatting about, I will go through and make sure that they are linked in the description. And I suppose it would be foolish of me not to also mention that we do sell all of these development kits at Electromaker if you do want to get started with them. There'll be links to those in the chat as well. But yeah, coming the long way around from sort of the Guitar Pickguard idea through to getting into Zephyr fanboyishness. I will make sure that all of those things are linked in the description. So that was just a very short edit of a conversation I had with Eli. I say short, it was still well over 20 minutes, but there wasn't, I found it very difficult to cut out. There was so much good stuff in the conversation, and that conversation will be published in full soon. But this is not the only thing that we have in this week's Electromaker Show, so without any further ado, let's get on with the show. A couple of weeks ago, we started a contest to win the Raspberry Pi 5, which is, of course, a contest that a lot of people were very interested in. The Raspberry Pi 5 is arguably one of the biggest releases in embedded hobby computing in a while, which is why we let the contest run for a couple of weeks. But now we have collected in all of the entries that left the hashtag Pi5, and it is time to announce the winner. And the winner is user EV2DR1HB2C. I do miss the days when you could actually see user names on YouTube. But yes, it says, I would use the Pi 5 to create a wireless smart apiary monitoring system, which is a very interesting idea for a project. I'm very much looking forward to seeing how that comes together. Please do post your results to the Electromaker project page when you do, and I'll probably feature it in this show. And of course, you may even end up winning our Electromaker of the month, depending on what our panel of judges think of it as well. But yes, congratulations. We'll be in touch with you as to how we can get the Pi out to you. Now, we will be running more contests in the future, but if you specifically had your eyes on a Raspberry Pi 5 and didn't win this contest but still wanted to get one, we have a large stock of them in the Electromaker store, and everything that is bought from that store directly supports this show. Now, we're going to move on to cellular IoT, and specifically the Waveshare BG95M30. And what makes this interesting is that there have been various hats that allow you to do cellular IoT that are compatible with the Raspberry Pi Zero or Raspberry Pi. In fact, several from Waveshare themselves. But this is different. This is a standalone single-board computer which works quite like a microcontroller in some ways, which is designed for cellular IoT. Now, as always, I'm going to go light on the details here, mostly because i.MX Software have covered this entirely. Their article goes through the entire specs of the board, including a few gotchas. Having read this article and also the Waveshare wiki page about it, both of which I will link in the description, here's just a couple of thoughts I had. So the first thing, and a thing I commonly forget to say, and I know it annoys some people, is how much does this cost? Well, it is €73.28 from AliExpress, which as always happens when you quote a price, people will say, but you can get a Raspberry Pi 5 for that much. And absolutely, you can. But this is doing something different. It is lower powered. It is an all-in-one cellular IoT platform. And that AliExpress link, by the way, is one that I just took straight from the bottom of this i.MX Software article that I have will be linking in the description. And this brings me on to my second point. Is it hat compatible? It absolutely is. It's designed to be Raspberry Pi hat compatible. Anything that will work on a Raspberry Pi Zero will work on this. Now, a couple of things I noticed looking at the Waveshare wiki page for this board. Firstly, it's not the only one in its family. This is the BG95M30. And by the way, the Waveshare listing for it is just $55, which is about €50. Don't know about postage or anything, but you might save a bit on the AliExpress listing if you buy it from Waveshare directly. There are also two versions of a board which is slightly larger but does much the same thing. However, it adds Wi-Fi and Bluetooth connectivity on top of the cellular connectivity. And these are both available for different regions for $58 as well. Now, to develop on it, you use MicroPython or QuickPython, which is their build of MicroPython for the hardware. And this is where things get somewhat interesting. It does say that there are plugins for Thonny and for VS Code, and it provides this tool called QPyCom. But then further down it says you need this QPyCom in order to flash the firmware on the board. Whether you will use this once and then you can use whatever you want, I don't know. I haven't looked into it enough at this stage. But it does appear that this is Windows-only software. And then you download this and you can then put new firmware on it, and that's how you get QuickPython on there. And then this will take you through a basic hello world. So again, if this is something that you are interested in, I would have a quick read through this and just check that the way that you work with it works for you. Because, yeah, I know that some people, it's a big turnoff if there's a Windows proprietary tool that you have to use to upload things. Most of these can be worked around, but if they're not a workaround right out of the box, it's going to waste a lot of your time. But yes, this does strike me as a very interesting idea, because as I said at the very start of this section, there's a bunch of hats that do this, and there are a lot of different cellular IoT products. We talked extensively about Blues and their range on the show. This is something a little bit different, and it's in a familiar form factor, and of course, if you have a big collection of Raspberry Pi hats, it's going to be a very compelling choice to add cellular IoT to a project that doesn't necessarily need the full Raspberry Pi system running on it, but you still want to get the benefit of using all of your different hats. But as always, I'm very interested to know what you think about it. Just a very quick reminder at this point in the show that while the general YouTube stuff is very much appreciated, like, subscribe, comment, click the bell, all the things that YouTubers ask for, you can support us in a very concrete and direct way. And that is by going to electromaker.io/shop and taking a browse of all of the things that we have there. We have Raspberry Pi 5s in stock right now. We have the NRF7002EK, as I discussed in the interview with Eli that you have just watched or maybe in the middle of watching, and a whole bevy of other products from every large manufacturer you can think of, and most suppliers too, including Adafruit, Sparkfun, and many others. So yes, electromaker.io/shop if you would like to support the Electromaker Show. Thank you so much for your support. Up next, we're going to very briefly touch on the Raspberry Pi M2 Hat Plus. And it is going to be very brief, mostly because we talked about it when it was announced. We talked about it at Embedded World when we saw it. And the simple fact of it is now available, and you can get it for $12. This is an M2 PCI Express hat that fits to the FPC connector of the Raspberry Pi. I always say FPC connector, but isn't the FPC... FFC, right? Yeah, the FPC is something completely different, which allows you to attach NVMe SSD hard drives or hardware accelerators for doing AI, things like that. So if you are interested in finding out more about it, I will leave a link to this in the description. This blog post covers pretty much everything you need to know about. It shows you where you can get it from various different Raspberry Pi resellers. There's also a fair bit of interesting information, just a little bit of backstory about it, and you can even jump into the Hat Plus specification, where they answer a couple of questions as to, why are we upgrading it? Why follow this specification? If you really want to get into the technical details of it all, you can. But yes, that's kind of it. This is the M2 hat, the official one from Raspberry Pi. Will you be getting one? And if you do, what will you be doing with it? We're going to move on to Breadboard OS, something that gives a Linux-like command line interface to the Raspberry Pi Pico, which is a wonderful project. And weirdly enough, one of the things I talked about with Eli, who I also interviewed in this episode, is the fact that you should always start with a command line. And without any further ado, let's take a quick look at it in action. So here it is. This is Breadboard OS over the UART, and they're talking to a command line on the Raspberry Pi Pico. Now, I appreciate that this is quite small. The video is vertical for whatever reason, and there's no way of me easily making this bigger. Maybe in post I can try and boost it up or something so you can see what's going on. But what you have here is a Linux type file system, and as you know, everything in Linux is a file, so you can cat various files to get things like the MCU information, to get the version. Later on, you'll see you can modify the pins this way as well. So if you're wondering where the GPIO pins and all the peripherals on the Pico fit into this, well, everything is a file. It's a Linux-like system. So for example, LED has its own alias, and you can cat it, and it says the LED state is off. Then you can put a 1 into the LED and it'll turn it on. And you can do this for all of the GPIO pins. And weirdly enough, if you got one of the Milk 5 Duo boards when they first came out, the tiny little Pi Pico form factor RISC-V basically computers that run mini Linux in their own way, that's exactly how you work with the GPIO pins on those as well. It's a different way of working, but if you're coming from a Linux environment and a single board computer environment, it might be something that you find interesting. It's certainly something that I was very excited to have a fiddle around with, and once I finish filming the show, I'm going to finish doing all of the building and things I need to do it myself. Anyway, that video that I just showed you was from the GitHub page that I will be linking in the description of this video, which is McKinley's Breadboard OS. And as it says basically, as its namesake implies, is a firmware platform aimed at quick prototyping. Breadboard OS was built around the following principles. Every project should start with a CLI. A command line interface makes prototyping, debugging, and testing about 1000% easier, especially over the lifespan of multiple projects with reused pieces. And again, write it once, don't waste your time rewriting the basic infrastructure, modularize, duplicate and profit, and get running quickly. It is a fork of Microshell, and it works with the Raspberry Pi RP2040, and it gives a bunch of different features as you would expect. A rich set of informational tools for checking system resources on the fly, a la PS, Top Free, and DF. The RTOS Task Manager, because in turn, Microshell is based on free RTOS, I believe. Unless the fork actually puts it onto free RTOS, that's something that I'm not sure about. That's something I'll look into to more a little bit later when I'm actually playing with it. But it shows you everything you need. It shows the general prerequisites you need. You need the free RTOS kernel and the Pico SDK in order to build the breadboard OS. Although, of course, once you've got those, you can then just drop the UF2 onto your Pico and do away with it if you want. Then you just have a Pico with a file system. So the GitHub is pretty good in terms of taking you through how to get started with it and to create your own applications. And I don't know, I just think this is a really nice idea. It's a completely different approach for working with the Pico. Of course, you can work in MicroPython and Thonny and just put your UF2 files across that way, or you can work with the Pico SDK and set up a debugger and have a more traditional C-based environment. But if you want something that just works out of the box with free RTOS to build your project on top of, this might be a really compelling thing to take a look at. Up next, we have a video from Andreas Spies on Halo, which is Wi-Fi using LoRaWAN bands, which is a very interesting concept, but it's one fraught with a few issues. Largely, if you live in the EU and you get an American kit for this, you are breaking the law. You are using the same bands as mobile phone companies use, and you're likely to get a very angry letter or someone showing up at your door. But it is a very interesting technology, and as always, Andreas Spies takes you through not only the idea behind it, he tests it thoroughly, and it goes quite deep into how you can make sure you get the right kit and don't fall foul of any laws. So yes, he tells you how to get the right kit. He tells you a few different ways you can test it. As to how well it performs, I'm going to leave that up to Andreas to explain. Please do go and check out the video. If you are interested in this as a general technology, he also gives you a few examples of the products you can buy in order to get started with this. But yes, if you'd like to know how it works through walls, albeit very dense Swiss walls, or over a long distance on different frequency bands, do check out the video. As always, Andreas's videos are full of information, but at a pace that is very easy to take in, which is one of the reasons why he's been my favorite YouTubers in this space for a very long time. That was our show for this week. Thank you so much for joining me. And please do let me know via email or in our Discord server what you think of the show. The email is ian@electromaker.io and the Discord server is in the show notes, along with links to everything talked about in this show. And a few extra ones just because there's some very interesting stuff Eli has chatted about with other people in the past that I think is worth hearing. I'd be very interested to hear what you thought of the Eli interview. What you heard today was a very heavily edited down version of it, frankly, because we chatted for almost 2 hours and the time flew, and I realized far too late that I was supposed to cut this down for a section of the show. But if you'd like to hear the full unedited version, that will be coming very soon. But for now, I hope you have a fun, safe, and creative week, and I will chat to you next time.